Gesture recognition app. In this section, we are going to develop an app capable of recognizing some basic gestures. In this video, I will describe a simple algorithm to perform gesture recognition. I will show the dataset and the model's architecture, and I will define what is batch normalization and cross-validation. In a general case where we have a picture and we have to recognize the gesture, there are several other problems that are at least as difficult as the gesture recognition itself. We basically have to detect where is the gesture, so where's the part of the image we want to crop and pass it to our model. And we also need to separate the background from the foreground. These two tags are very important because otherwise we will pass a lot of irrelevant data and noise to the model, and we want to avoid that. What we will do to keep it simple is to pretend we are designing an application for a mobile device which is always located in the same position, in a factory for instance, and expect people to only show gestures directly to the camera. Then, in order to remove the background, we will perform the simplest operation possible, which is background subtraction. That's why we are implying that the background is always the same, and at the end we will have a black and white image in which the background and the hand or arm have different values. Afterwards, since we want to get rid of useless pixels and mainly focus on the gesture, we will find the borders of the foreground and then crop just that part. Then our model will expect a square input for this. So if we resize it, the gesture can be distorted, and this might affect and give some problems to the model because it might result in an unrealistic gesture. What we will do is to first paste it in a square background and then resize it to the desired dimensions. Our dataset will consist of 9 pictures, 3 pictures per gesture, so we will perform a data augmentation to make our model more robust. In this case, we will just rotate the pictures from -45 degrees to 45 degrees in a step of 5 degrees, because it's very unlikely that we will give the gesture completely rotated. It's important to understand well the scenario where the application will be used to not provide with useless training data that it won't probably see. In addition to the image input, and in order to make a more interesting and complicated model for teaching purposes, we will provide 2 more inputs. We will sum all the elements in the image in both axes, resulting in 2 vectors. Now let's take a look at how the model looks like. To start with, I will reuse the model in the previous section. I simply change here the dimensions to adjust to the new input size, which will be 60. Then, as I've said before, we will have 2 more inputs. We will concatenate them, and then we will pass them forward through a dense layer, resulting in a hidden layer of 200 neurons. Finally, we will simply concatenate this to the layer we had before, and that's all. The model you can see here is the result of adapting another thing I had in mind to do in TensorFlow. What I originally wanted to do was having just a single input, and in TensorFlow generate the other 2 vectors by summing the input in different axes. Unfortunately, as mentioned before in the beginning of the course, TensorFlow Lite does not support some operations, including this reduced sum. What they say is that there are a bunch of simple operations, like the one I'm trying to use, that we can easily replace them by other placeholders or just make them as a combination of other allowed operations. I guess this is just to keep TensorFlow Lite model simple. But for this reason, I'm directly giving the TensorFlow model the 3 different inputs. Otherwise, I would just compute it. In addition to the model, we will use batch normalization, which is usually used in all the state-of-the-art models nowadays. Although it improves accuracy sometimes, the main advantage of using batch normalization is that the model converges much earlier and the training period is therefore much shorter. The main idea of batch normalization is to normalize the inputs of each layer per batch before multiplying them and going forward. Imagine each batch has a different distribution. The network will be constantly adapting to these variations, and for this, what batch normalization is doing is just to shift and scale each batch appropriately by lambda and beta. These new parameters are being learned during the training based on the batch mean and variance in each batch, right? But during testing, we are looking for a deterministic solution. So the values of mean and variance will be calculated over the whole dataset. Unfortunately, the function used to perform batch normalization in TensorFlow cannot be converted to TensorFlow Lite, but we will use it in the model anyway because it's important to learn how to use it. Finally, one more comment about how I split the data to create training and testing datasets. When I split the data, I know that I'm getting one image after another, and the data is deliberately split in the most convenient way to have the same number of training samples from each image. So if you're developing something like this, you should make sure your model will train on all data, right? However, in other problems, we will have millions of data randomly distributed, and we don't know how good is split. In fact, we might have a very different accuracy depending on how the data is split. I already mentioned this in the second section when talking about overfitting, but one common approach is to divide the dataset many times and train and test on different splits. This is called cross-validation, and in our model, we may have worse results than if we split the data in a clever way. But it's important to learn how to do cross-validation because it's widely used in machine learning. For this reason, I will show how to use it, but I won't use it to choose the best configuration, because for that I would prefer to use the splits that are split in a clever way, right? In the next video, we will start creating the model.